Okay, let's finish up this problem here. So here's all the stuff, free body diagram of that beam. And first of all, we look at the moment around this point, point D, and the perpendicular forces. So that would be a clockwise moment, FAB, sine of 75 degrees, perpendicular to this line. Okay, these two forces contribute no moment. This force is clockwise. 1 meter, 0.25 plus 0.75, 1 meter times F. And we go through the calculations, we get 3313 newtons for FAB, for this link right here. This is pushing up with 3313 newtons, pushing down with approximately 800, and that means NW is also going to have to push down. We notice down here, when we get the NW equation, that is the vertical, we're looking at the y direction, FAB cosine 45 plus NW minus F cosine 30. Well, this is much bigger than this. So we expect NW is going to be negative, and sure enough it is. And that makes sense. This is like a lever arm. Oops, it's pushing up. It's pushing up. So NW actually has to be pushing down. The arrow has to be reversed. This negative sign means the arrow has to be reversed. Okay, X direction equation. FAB sine of 45 degrees, and it's a positive X direction. P is the negative X direction, and F cosine 30 is also negative X direction. Negative X direction. So then we solve it for P equals 1943. So you do get you have 800 newtons here. A person operating this would be pushing down, so they could put their full body weight into it, and then the force P then is a little more than double that. So that's like twice your body weight, when you're exerting it with your foot. And instead you have a machine that does the same thing. Okay, we'll take a look at an elevator pulley system next. 500 kilogram, neglecting the mass of the pulleys and the cables and things like that. So here's the elevator system. We only have to worry about the vertical. You'll notice that the normal forces here on these rollers will sum to 0, and all the other forces are vertical. So we have a T2 on pulley E. Just looking at this part of the free body diagram, this is another cable, T1s. All these three are T1s, these are T2s. And the 500 kilograms downward, and then pulley C, T1s and T2. So that connects T1 and T2. And pulley B, we probably don't need to worry about unless we wanted to know how strong this joint needs to be. Okay, so just a lot of working through. That you can see T2 equals, oops. Okay, might as well move on. There we go. So T2 has to equal twice T1. That's pretty obvious from this free body diagram. 3T1 plus 2T2. Well, T2 is twice T1. So that's 3T1 plus 4T2. T2 is twice, oops. Boy, my tablet's acting weird. Okay, T2 is twice T1. I'm just checking something. Okay. Whenever I touch my pen tab, it goes and does something. So I need to be sure and turn it off. There we go. Get rid of all that crap. So this is 4T1 plus 3T1. 7T1 is equal to this number right here. So these, this really isn't that tough to figure out. I'm going to pause for a moment. I'm going to double check these numbers on my calculator. Okay, I just got done double checking. I agree. 707, 701 newtons, 1401 newtons for T2, 701 for T1. I wanted to get to this one because we have a distributed force right here. It can be considered to be acting at 1 meter. Remember, we can substitute as far as reactions. That would include the reaction at pin B. It can be considered to be acting at 1 meter. It's 400 kilonewtons per meter over 2 meters, so that's 8 kilonewtons. Oops. There we go. And you see that right here. Got a pin joint here. You have 10 kilonewtons acting here, which breaking it down into its components. Oops. So we're going to have two forces like so. And this one's going to be 4/5 of 10, or 8 kilonewtons. This one's going to be 3/5 of 10, or 6 kilonewtons. Okay. And then, of course, at the rocker here, C, we're just going to have a vertical force. Now, at the pin B, we match up. By positive on the right-hand side, negative on the left-hand side. Bx positive on the left-hand side, negative on the right-hand side. Then we have this. Now we have a fixed support here, so we're going to have AY, AX, and a moment. And we'll draw the moment counterclockwise. So this is a reaction moment. I think we've got all the forces listed. Yes, and broken down into two different FBDs. FBD1 for the left-hand member, FBD2 for the right-hand member. And I would wonder if we could calculate the overall reactions. We have 3 equations and 3 unknowns. We have 4 unknowns, though. We have C, AX, AY, and MA. We have 4 unknowns. So we got to go to these individual FBDs, as well as maybe an overall FBD. Although this generates 6 equations. Well, actually it doesn't. This is 2 equations here. Because remember, if it's a 2-force member, no moment, but it's actually a 3-force member. So this could be up to 6 equations. And we have 4 unknowns. So we got to pick, try to figure out the easiest way to solve this. So segment BC, some of the FX forces is 0. That means BX has to be 0. I'll just cross it out. These two have to be 0. Next, moment about B. So let's take a look at that. That means we're going to have the 8 kilonewton force here acting counterclockwise at 2 meters. And we're going to have an MA plus MA minus AY times 4. So let's see. 8 kilonewtons MB. Okay, BC. They were looking at BC. They weren't looking at AB. BC, moment about B. 8 kilonewtons times 1, negative 8 kilonewtons times 1 because it's clockwise. CY times 2 because it's counterclockwise. So this lets us get at CY. It's got to be 4 kilonewtons. So earlier we saw an example where you really didn't need frames and machines to solve the problem. This one you do. Okay, now, so BY, this is going to be, we can substitute the 4 kilonewtons in here. So BY is going to have to equal 4 kilonewtons also. So 8 minus 4 has to equal AY, or excuse me, I'm sorry, the 8 and 4 are both acting downwards. So that's negative 12 plus AY. So AY has to equal 12 kilonewtons. The moments, probably taking the moment about A would be smartest. Okay, but we've gotten as much information as we can out of these two. BX equals 0. Okay, segment AB. So summation of f of x equals 0 means the AX, BX is 0. AX minus 6 kilonewtons has to equal 0. So AX has to equal 6 kilonewtons. Summation of the moments around A. And that's what I would have chosen. Because then you get rid of all the reaction forces at A. You just have MA. You have a negative 8 kilonewtons times 2 and a negative 4 kilonewtons times 4. So negative 8 kilonewtons times 2, negative 4 kilonewtons times 4. That's 16 and 16, 32. MA is 32 Yeah, 32 kilonewton meters. Then finally, AY and BY, summation of forces in the x direction. BY is 4, so that's negative 12. AY has to equal 12. We already figured that one out. There we go. And previously we figured out BX equals 0, CY is 4, and BY is 4. Yeah. Okay. So, good time to end. We're going to pick up this problem in the next video.